Good afternoon, my name is Anlei, and today I will be talking about building serverless applications with AWS Lambda. But before diving into what serverless means, let's talk about how traditional apps are built and deployed. This is a very familiar thing for us. We know that the browser interacts with the server and interacts with the database. But when your backend code runs, you need infrastructure in the backend to run all this code. For example, if you want to generate in-action purchase during your gaming session, you would need your code to trigger whenever there is an in-app activity or there's an image upload. And the architecture will look something like this for an online store, for example. But that means that you need physical servers in-house, or you need virtual servers from providers like AWS. However, there are a few issues with this. You are still charged for keeping your servers up, even when you are not serving out any requests. You're responsible for uptime and maintenance of the server, as well as any security updates. And as your usage scales, you need to manage scaling up your servers as well. For smaller companies and individual developers, this can be a lot to handle, and this ends up distracting you from the more important job that you have, which is building and maintaining the actual application. This is when serverless comes in and saves the day. Serverless architecture offers the promise of writing code without worries of ongoing server administration. Serverless was first used to describe applications that significantly or fully dependent on third-party applications to manage your server-side logic and state. So you can think of the term in the cloud. These are typically rich client applications, so think of single-page web apps or mobile apps that use vast ecosystem of cloud-accessible database like Firebase or authentication service like OAuth or AWS Cognito. These are called backend as a service. There's also another type that is a function as a service, and what that means is that you are uploading your function, your backend code as a function, and AWS, for example, in this case, Lambda, would be managing this backend code as a function, and it will only be triggered per event, and it is fully managed by a third party. So what is AWS Lambda? Obviously, it's a serverless compute service that runs your backend code in response to events such as when you upload to your storage or updates to the database. You will no longer need to worry about provisioning or managing servers. All you need to do is supply your code in one of the languages that Lambda supports. Serverless computing allows you to build and run applications and services without thinking about servers. It will then allocate the appropriate amount of resources to respond to the usage. On our end, we only get charged for the time it took to run our code and the resources that it consumed. Additionally, our code runs in the secure environment where the cloud provider takes care of keeping the server up to date and secure. In order to gain first-hand experience on AWS Lambda, I have built an app using AWS ecosystem. My app is built in Node.js with the backend using Lambda and API gateway and the front end using React. I use S3 to host my site assets, Cognito for authentication, Gateway for my API request, which will then talk to Lambda, and in turn, it will talk to DynamoDB. So let's take a look at the app that I built very quick. Let's see. How do I do this? Great, OK. So this is a very simple note-taking app. I use AWS Cognito to log in and log out. Let's just log in as me. It's a very simple CRUD app that we have built here, where you can create node, you can edit or delete the node. Great, but the more interesting part is if you go to my API gateway, now my backend is packaged into requests. And if I click on one of these requests, you can see that the post request is talking to my Lambda functions. And when I go to my Lambda functions, great, I now have 5 functions that basically runs my backend. And if I go to one of the functions, the create functions, you can see that the code is in Webpack format. And the trick is truly API gateway, because that's what I told it to do. Also, another note, I use serverless framework, which is a very easy way to create and deploy your serverless application. And because Lambda also supports integration with other APIs, such as Alexa, I decided to embark on a more exciting adventure, which is to build a new skills for her. This is my developer console in Alexa. I created a new skill with 4 intent. The intent corresponds to my Lambda functions, which is to add, get, update, and delete the node. So let's test one of these skills. Alexa, add a new node.
What do you want to add?
Ice cream.
Your node is added.
So if I go to my app, I should see that ice cream is added, and it is. And so now I am able to tell Alexa to connect to my app and talk to my app. In summary, I was able to use the whole AWS ecosystem to build my app with the backend functions in Lambda that can scale to millions of users. I would encourage you to build a simple app in AWS console. This will be very beneficial for you as a developer, as many employers or companies out there are using some type of AWS services, and for you to just understand the architecture of your own app. Thank you.